Okay, so here's where we are. Today we're talking about the last lesson in this unit. It's similar triangles. We're talking about similar triangles. So what are the theorems that we've learned so far? What are the theorems that we've learned so far to use to prove that our triangles are congruent? What have we learned? What are the theorems that we use? How do we prove triangles are congruent? You should be on page 40. What are some of the theorems that we've learned? Anybody? I mean, you have your note packet right in front of you. Look at the triangle congruence theorems that you've learned already. Chandler, what is one theorem that you've learned to prove triangles congruent? Where's your note packet? Side angle side. Where's your note packet? Get it out. What's another one? Angle side angle. Side side side. What else? We have one more that has 3 letters. Say again. Yeah, angle, angle, side. And then we had one that we use specifically for right triangles. Hypotenuse leg. So those are the 3 theorems that we have, or the 5 theorems, sorry, that we have learned to use to prove that triangles are congruent. We're going to learn 3 theorems that let us prove triangles are similar. So now we're going to talk about triangles being similar. Similar means that they have the same angle measures, but the sides aren't equal, they're proportional. The sides are not equal, they're proportional. So angles are the same, and the corresponding sides are proportional. That's what that says. Corresponding sides are proportional. Okay. So the first one that we're going to look at is angle-angle similarity. And it says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. Then the triangles are similar. Why is that? What do we know from the triangle sum theorem about angle C and angle H? There's nothing on angle C and angle H, but what do we know from the triangle sum theorem? What is the triangle sum theorem? Everybody close their Chromebooks. Close them. What is the triangle sum theorem? It's in your note packet. Maybe you should look. It's the first thing you learned on this whole chapter. Triangle sum theorem. I think it says that if you add up the what? If you add up the angles of a triangle, what do they equal? 180. They equal 180. So if A and F have the same measure, and B and G have the same measure, that means if I add those two up, they're going to equal the same amount, correct?
Yeah.
So what can you say about C and H? They're from two different triangles. Do you need numbers in there to like process? What if I put I said this was 96 right here. This is 96. This is 34. This is 34. What can you tell me about C and H? They're congruent to each other, yes. And I drew several pictures on the board to show you that just because all of the angles are the same doesn't make the triangles congruent. It makes them similar, right? So it could be different sizes. So that's your first theorem. Angle, angle, similarity. Let's look at your next theorem. So the next one is the triangle similarity, side, side, side. So it says that if the corresponding sides and the side lengths of the triangles are proportional, then the triangles are similar. If the corresponding sides, I need to make that go away. It's not working. If the corresponding sides of the two triangles are proportional, then the triangles are similar. So if I said that this had a measure of two, I can't write on anything at all. 2, 4, and 6. If I were to sketch that out and I said that the first triangle had sides of 2, 4, and 6. So this was 2, this was 4, and this was 6. If they're proportional and this is 6 right here, what would the other measures have to be? How would you solve something like that? What does it mean for the sides to be proportional? Well, MQ is proportional to JL. So 2 is to 6 as MP is to JK, which is 4 over, we don't know the other measurement, right? 4 over, we'll call it X. Could you solve for that? Yeah, it's a proportion. We solve a proportion by using cross multiply. 6 times 4 is 24 equals 2 times X is 2X. So 12 equals X. So that's what it's saying. It's saying that the sides are proportional, meaning you can set up a proportion to solve and find the missing measure. The other theorem that we use to prove that triangles are similar is side angle side similarity. If the lengths of two sides of one triangle are proportional to the lengths of the other two, and the included angles are congruent, then the triangles are similar. So we're just going to jump right into some practice. So everybody should be on the next page. Okay. All right. So determine whether the triangles are similar, and if so, write a similarity statement. So the first thing that I want to draw your attention to is this. What does this symbol mean right here? What does that mean? Those two red triangles on the drawing, on the picture that you have in front of you. What do those triangles mean? Those two markings on the side. What does it mean about the sides? Mylena, pick your head up, okay? Get your hand off your head because you're going to fall asleep on me. What does it mean? We've seen those markings before. What does that mean about those two lines? Elizabeth, what does it mean? That they're parallel. Thank you. It means they're parallel. So if I have two parallel lines cut by a transversal, what do I know about the angles? What do I know about this angle and this angle? Why? Good job. alternate interior angles are congruent. So I have those two angles marked. What do I know about these two angles? Why? Yeah. Vertical angles are congruent. So I can say that triangle X, Y, Z is similar, and the similar symbol is just this little squiggle, is similar to triangle W, V, Z by angle similarity. I can say that they're similar by angle similarity. I'm going to go to number 2. So what do I know about what kind of triangles are the two triangles in question number 2? They're right triangles. Okay. So notice that I don't know the hypotenuse on triangle ABC, but I do know the measurement of the hypotenuse on triangle EFD. How could I go about finding either the hypotenuse or the other side? I need to find one of those measures because I don't have the same sides to compare to each other. So what I'm saying is, do you guys see that I have side A, which corresponds to this side, but I don't have the other measurement that's nestled on the other side of the right angle. So I either need to find that using something that you know, or I need to find the hypotenuse. I need one of those measurements. So either find a missing leg or hypotenuse. How am I going to do that? How do we find the missing side to a right triangle? Say it. Nope, we're not going to add them all up. Begins with a P. I heard someone say it. Pythagorean theorem, a squared plus b squared equals c squared. So the Pythagorean theorem says that the square of the sides, 3 squared plus 4 squared, sums up to the square of the hypotenuse. So what is 3 squared? 3 times 3 is 9. And what is 4 squared? And what is 9 plus 16? Okay. So if 25 equals c squared, then what does c equal? It equals 5. That means that this side has a measurement of 5. So now I can set up a proportion. I'm going to compare the 2 blue sides and the 2 yellow sides. So 3 is to 6 as 5 is to 10. I want to prove that they're proportional. How do I do that? How do I prove that those make a proportion? Cross multiply, or I heard you say simplify. Yeah. Whoops. So I'm going to cross multiply first. That's going to give me 30 equals 30. Or if I simplify my 2 fractions, I get what, Aiden? You said simplify. Yeah, they both equal 1/2. Okay. What do we know about right angles? What do we know about this right angle compared to this right angle? They're the same, right? They're congruent to each other. So I can say that triangle ABC is similar to triangle FDE by side angle side similarity. You have to show that the sides are proportional. You have to show that they're proportional. So for that one, we had to use the Pythagorean theorem, right? I'm going to go over to number 3. I'm going to go over to question number 3. I don't know where I put your filled out notes. Question number 3. What sides correspond to each other? What sides correspond? What are the corresponding sides? How can we set up a proportion to prove that those are similar to each other? Okay, well, probably VU has to be similar to VH. Is that what you're thinking? Do you guys understand how multiples work? I know that you do. You understand multiples, right? So what if I were to compare side TU to side TV? What do I get? I'm just looking at this triangle right here. What is the fraction TU over TV? What is the side measure of TU? 6 over 8. Okay. So is there a way for you, and what does that reduce to? What is 6 over 8 to reduce to? 3 over 4. Okay. Is there a way, looking at this triangle, to set up any type of proportion, regardless of what sides you compare? Is there any way that you're going to end up with 3 over 4? Say it again, Aiden. No, there's no way that you're going to be able to get a fraction 3 over 4 with the numbers that you have, 4, 5, and 8, correct? Does that make sense to you? So this is not similar because they are not proportional. Okay. Let's look at example number 4. So I'm going to do that same thing. I'm just going to pick 2 sides. I'm going to pick side JK and side KL. So that's going to be the proportion 20 over 15. What does that reduce to? What does 20 over 15 reduce to? 4 over 3. Is there any sides that I can compare, set up a proportion, so that when I simplify them, I get 4 over 3? Not 6 and 4. How about these 2 sides? So I'm going to compare 8 to 6. So those come up with the proportion what? What do we get? 4/3. Okay. So what if we look at these 2 sides? So we have to compare those. So let's say that I set up the proportion. So I'm just working around the triangle. So I set up the proportion 10 over 20, which is 1/2. And the proportion 4 over 8. Do I get the same measure, 1/2? Yes. So these sides are all proportional. So triangle JLK is similar to triangle SRQ by side, side, side similarity. I'm going to set it up another way for you to try to figure out like how to set up a proportion. I'm going to do one more thing. If you can figure out the layout of the sides, and you just take the smallest, like do small, medium, large, right? So the small side compares to the small side. The medium side compares to the medium side, and the large side compares to the large side. If this is a true proportion, what will happen? What will those make? Yeah, 15 is not 3. This should be a 6. Sorry. You guys are just letting me do all kinds of crazy math here. This should be a 6. So what do I get when I multiply those? What's 4 times 15? 60. And what's 10 times 6? Okay, what if I did the proportion this way? 15 times 8 and 6 times 20. Don't I get 120 equals 120? Yes. Okay, so you're going to have to learn how to set up proportions, but you're going to have to differentiate the sides. So maybe it'll help you to think of the sides in terms of like how big they are, small, medium, large, to set up your comparison. All right, so identify the similar triangles. We're going to have to find out how they're similar to each other and then find the missing side. We know that they're similar. It says that they're similar. We just have to figure out the way that they're similar. So notice that angle J and angle X are similar to each other, but also angle K and angle Y are both 51. So what does that mean about Z and L? Yeah, they have to be equal to each other. So I'm going to start with X, Y, Z. So triangle X, Y, Z. So I started with the pink angle. Pink, yellow, nothing is similar to, I'm going to do that the same on the next one. Pink, yellow, nothing. Triangle J. Okay, Mylena, take your head off your arm. Sit up. So what rule am I using? What theorem is this? We have 3 similarities. Is it side, angle, side? Do we know anything about a side? Is it side, side, side? Do we know anything about a side at all? What's the first similarity rule you just learned? By angle, angle. Okay. Dylan, how are you able to see the notes if you're facing away? I want you to sit where Charlie's supposed to sit so you can actually see what's going on. Okay. Thank you. So how are we going to figure out the measure of KL? How are we going to figure out the measure of KL? Any ideas? Well, 5 has to compare to what? 4. Let's set up a proportion. As 15 compares to X. So what does that give me when I use cross multiplication? 60 equals 5X. 12 equals X. Next one. So I know that the triangles are similar. It says that they're similar. So I just have to figure out the missing measure, right? So I have this little triangle right here that I'm comparing to the big triangle. So someone set up a proportion for me. This side compares to this side. What is that? This side is my first fraction. What does that become? Three over 5 is 2. Now let's do the bases. What's the base of the small triangle? 12. And what's the base of the large triangle? It's this whole measurement right here. What is that measurement? You guys can see that, right? It's X. So cross multiply. 60 equals 3X. When I divide, I find out that X equals what? 20. Flip it over. Okay. Determine whether the triangles are similar. If so, write the similarity statement. If not, what would be sufficient to prove that they're similar? Explain your reasoning. So, like if they're not, what could we add to make them be similar? So for this first example, again, you have a small triangle kind of hidden or nestled inside of this big triangle. So we have to compare all of the sides. We're going to compare all of the sides. So I'm going to start with this small side right here compared to the whole side right there. What does that become? What's that proportion or that fraction look like? What's this measure compared to this whole measure? Anyone? It's right in front of you on your paper. You're trying to read the board and you can't. What is the number on your paper? What's the one that I have circled? 5. And then what's the whole side length? 5 plus 2 is what? 7. Toby, pick your head up. Okay, we're going to go to the next side. So I'm going to compare this to the whole thing. So the small piece is what? The small piece is, and the whole thing is whatever 8 plus 3.2 is, 11.2. Equals, now I'm going to do this last side right here. The small side compared to the larger side. So what's that going to look like? 10 over what? 10 over 14. So let's see if it's proportional. What is 7 times 8? And does it equal 5 times 11.2? Pick up a calculator. What is 7 times 8, TJ? It's 56. What is 5 times 11.2? It's 56. Okay, let's check the next leg of our proportion. No, I need you to stop interrupting me, please. What is 8 times 14? Use your calculator. 112. And 11.2 times 10 is? So these are proportional. So triangle UWY is similar to triangle UXZ by side, side, side similarity. Side, side, side similarity. What about this next one? Do we have enough information to say that those are similar to each other? Nope, there's not. There's not enough info. I'm going to tell you what we do know. We do know that angle A is congruent to itself. If we knew that B and C were the midpoints, that would be enough information. Or even if we knew that BC was parallel to DF, because then that would give us the angles. But we don't know. We don't have anything marked, so we just say not enough info. Okay. What about example number 11? Or what number am I on? 10? Yeah, number 11. So I have two congruent angles. This angle right here is congruent to that angle. I have this side right here, hopefully proportional to this side right here. And then maybe this side right here, which is 9, is proportional to this whole side. So what proportions am I going to set up to prove that it's similar? Let's compare the two red sides first. What are my two red sides? 6 and what? Oh, 10 and 6. Okay. So you're going to do the larger to the small. So 10 is to 6 as, what's the yellow side of the large triangle? What is the yellow side of the large triangle? 9 plus 6 is 15 over the yellow side of the small triangle, 9. Do you guys see where we get that? Let me erase this so you can see what's going down. So if I'm just looking at the small triangle, this small side is 9. When I compare it to the large side of the large triangle, this whole side is 6 plus 9. That's where that 15 comes from. Cross multiply, 90 equals 90. So triangle ABC, that's the large triangle, is similar to triangle FBD by side angle side similarity. Use side angle side similarity. Number 12. Determine whether triangles are similar, and if so, write a similarity statement. If not, what would be sufficient to prove? We're just going to write not enough info. So notice in this example, I have triangle JKP, and I'm comparing it to triangle JLM, but I have a pair of parallel sides. So I can say that angle J is congruent to angle J. It's congruent to itself, right? Do you guys see that I have two triangles nestled inside of each other? This is JKP, and then the larger one is JML. So J is congruent to J. That's for sure true, right? But what can I say because of these parallel lines? What does that make these two angles? Why? What kind of angles are they? They are in the same spot. They lie in the same spot on both lines lie in the same spot on the transversal. What are those called? What kind of angles are those? You guys remember corresponding? They're corresponding angles. And we know that corresponding angles are congruent. So triangle JKP is similar to triangle JLM by angle similarity. Mylena, open your eyes, hon. If you can't keep yourself awake, go stand at one of the standing tables so I don't have to keep asking you to open your eyes. Number 13. So, I have angle 62, and notice that angle 62 is nestled right in between on the larger triangle in between two sides. Do you guys see that? But when I look at the smaller triangle, that angle 62 is not nestled in between two sides that I know measures to. So is there any way that I could figure out the measure of one of those sides? Do we know how to do that from just a basic triangle, or is there not enough info? Say it, Aiden. No, not enough info. Let's look at number 14. Number 14. So we're going to probably have to use triangle sum theorem, I think, here. So I see that this angle Q is congruent to angle V, but 59 and 68 aren't congruent to each other, but possibly U could be 68. I don't know. I need to check. How do I figure out what this measure is right here? How do I find it? Add them together. 180 minus 47 plus 68. If these triangles are similar to each other, then this sum right here will equal, it should equal 59. What is 180 minus 47 minus 68? You all have calculators on your desk. I'm not picking up a calculator. What did I say? I'm taking 180 minus 47 minus 68. It equals 65. So that means that this measure right here has to be 65 degrees. Well, 65 doesn't equal 59 and 68 doesn't equal 59. So that means that these are not what? These are definitely not similar. They're not similar. Not similar. Okay, almost done. Almost done. So we have number 16. It just says to identify the similar triangles and then find the missing piece. So I know that the two triangles are similar, and I know that because, well, I have angle J congruent to angle P, and I have angle JLK congruent to angle PLM. Why? Why are those congruent to each other? Yeah, those are vertical angles. Okay. So let's see. That means that 4 is to 6 as x is to 12. That's how I'm going to find that missing side. 4 over 6 has to equal x over 12. So cross multiply, 6x equals 48, which means x equals 8. Okay, let's look at number 17. So I know that these two triangles are similar because angle Q is congruent to itself, and I have parallel lines, which means that angle R is congruent to angle P. So I know that those two triangles are congruent. Let's set up some proportions. Let's see. How about if I said small triangle, 12, the base of the small triangle is to the base of the large triangle, 16. And that has to equal the small side of the triangle, side of the small triangle, compared to the side of the large triangle. So 16x equals 240, which means x equals what? Pick up your calculator and divide. X is 15. Okay. So for the next one, so it asks us the measure of ST. Do you guys see that? It's saying, hey, what is the measure of ST? Well, if X is 15, what is ST? Yeah, this is 15 and this whole thing is 20. So ST is 5. Do you see how we did that? This is 15. We just solved for X and we said X is 15. But this whole thing right here is 20. So 20 minus 15 is 5. Okay. All right. So for this next triangle, I have triangle ZUW. So that's the first one I'm looking at, triangle ZUW. And then I'm going to start at WUY. It's got to be similar to triangle WUY. So let's see some measurements. What do we know? We know that WY is 40. That's the first letter and the last letter. What can I compare that to? Well, do we know what ZW is? 3x minus 6. Okay. We also know UY, which is the last two letters. Do we know the measure of UW? Do we know the measure of UW? Nope. Can we find the measure of UW? What kind of a triangle is this? It's a right triangle. We have to use the Pythagorean theorem. A squared plus B squared equals C squared. C is actually that measure 40. That's your hypotenuse. So A is going to be our unknown side. Plus 32 squared equals 40 squared. A squared equals, what's 40? That's 1600 minus 32 squared. What is that? Someone figure that out. 40 squared minus 32 squared. Okay. What is the square root of 576? Yeah. So this side is 24. All right. So I know that UY is 32 compared to UW, which is 24. So that's the proportion I'm going to set up for this one. So 40 times 24 is, I think it's 960. Yes. And 32 times 3, 96x. Minus 32 times 6 is, I think it's 192. Someone better be checking my math. Okay. So let's add 192 to both sides. So 960 plus 192. I don't know, 1152 maybe. Yeah. Divide both sides by 96. X equals 12. So X equals 12. But that's not all we have to do. We also have to find the measure of WZ. And we have to find the measure of UZ. So let's see. WZ is 3x minus 6, or 3 times 12 minus 6, which equals, what's 3 times 12? TJ, pick your head up for me. 36 minus 6 is 30. So WZ is 30. What about UZ? Well, UZ is x plus 6. So that's 12 plus 6, which means that UZ is 18. Okay. Do you guys feel like you have this? Yes? No? Who said no? You don't understand this? Okay. I'm going to do one more. I'm going to do number 20. I'm going to do number 20. And then I'll just post the filled out notes. Okay. So jump down to 20. So I have 2 right angles and then 2 outside angles. So the way that you want to think about these CFD triangle, CFD, I went from the 22 to the 90 to the unmarked angle, is similar to, I have to do it the same exact way. Triangle BFD, or sorry, this is CF. This is an A. CFA is similar to triangle BFD. All right, so let's set up some proportions. So let's see, CF is 12. Well, that's the first 2 letters. That's got to be the same as BF. So 12 over 2x minus 1 equals, well, I have CA. That's the first and the last. It's the first and the last letter of the name. 20 over, well, that's the same thing as BD, 2x plus 1. Okay. Cross multiply. 20 times 2x minus 1 equals 12 times 2x plus 1. Distribute. So I have 40x minus 20 equals 24x plus 12. So now what am I going to do? Subtract 24x and add 20. So 16x equals 32, which means x equals 2. All right, so x is 2. We have to figure out those missing sides. So what is the measure of dB? So 2x plus 1. Well, that's 2 times 2 plus 1, which is what? 5. We also have to find the measure of CB. CB is the whole side. So do you guys see this? 2 times 2 minus 1 plus 12. So what is that? 15. Good job. It doesn't even ask us about dB or FB. We just kind of incorporated that in there. Okay. All right. So I'm going to get our